Now we need to create the finish cuts on the outer profile, the open pockets, and the closed pockets. 2D contour is a toolpath to finish mill a profile at a specific Z depth. These profiles can be internal or external, open or closed. You have the capability of creating multiple Z steps to cut down or multiple side cuts on the profile. But the cutting motion always takes place on a 2D plane. A single 2D contour toolpath can contain multiple chains, and each can be cut to its own specific depth, as long as the cutting parameters are the same, meaning they will use the same feed, speed, and number of cuts. The 2D contour icon is available directly on the 2D toolbar group. It can also be selected from the 2D toolpath pull-down. From our previous lesson, we determined that the smallest inside radius is 150 thousandths. So we will need to select a tool that will fit within that parameter. Press Select to enter the tool library. If you click on the document heading Intro to 2D Machining, the middle section will show only the tools for this project. Pick tool number 3, the 1/4 inch diameter flat end mill, from the list and press Select. For now, we will leave the default speeds and feeds for this tool. Let's go to the Geometry tab. There are many areas on this part that require a finish contouring toolpath. When selecting the geometry, we only want to pick multiple contours if they will have similar cutting attributes. We know we want to cut around the outside of the part. As before, we will want to cut past the bottom of the lower edge, just as we did with the adaptive toolpath we used for the outside. We don't want to cut past the bottom edge on the pockets. That would ruin the part. So for our initial toolpath, we're going to pick this bottom edge. Let's go to the Heights tab. Our bottom height should be set to From Selected Contour, and we want to set the offset depth to -30 thousandths. So we will cut past the bottom edge of the part. Let's go to the Passes tab. 2D contour is almost always used as a finishing cut. This means we need to hold the final size based on the tolerance and the part requirements. While Fusion will calculate the toolpath to the highest resolution that the machine can accept, there are factors that can make holding that tolerance difficult during the machining process. Tool wear is the biggest problem in controlling the tolerance at the machine tool. We need a way to provide the NC machine operator some control over the final size of the cut. This is done with cutter diameter compensation, sometimes referred to as cutter radius compensation, but more commonly known as cutter comp. To provide the NC operator with the control he needs, we will be setting the compensation type. I suggest that you read the tooltip for what each of these options will do. To allow cutter comp at the machine, we need to set the compensation type to either wear or inverse wear. This will output the code to provide compensation to the left or to the right of the programmed path. The actual code will depend on the specific NC machine control requirements. The most common codes are G41, which is cutter comp left, and G42, which is cutter comp right. For our example, set the cutter compensation type to wear. Some of the other parameters you may find useful are roughing passes and multiple depths. Roughing passes will take additional side cuts on the part. Multiple depths will take multiple steps going down in Z. For now, we're going to leave those off, but I encourage you to look at the tooltips and play with those options at a later date. Check the box to enable smoothing again. Let's go to our Linking tab. You never want to drop your tool right on the edge of the part. To avoid that, we have something called leads and transitions. Lead in blends onto the part, and lead out blends off of the part. You can control the distance of these lead in, lead out with these parameters. It creates a series of arc and line moves for a smooth transition onto the cut. Examine the tooltips for details of what the individual parameters are controlling. We are going to leave these set to their defaults. These values are set by a formula based on the tool size. Right-click your mouse over the parameter and select Edit Expression to see the formula. Of course, you can change these formulas, as we learned in our previous lesson. Typically, you would want the lead out to be the same as the lead in. However, you can disable this and make your lead out a completely different set of values if you want. With those changes complete, we're going to press OK. There is our 2D contour toolpath around the outside part. In this lesson, we learned about the 2D contour finishing strategy. Selecting a new tool, cutter compensation, the potential to take multiple cuts in XY and in Z, using the lead in and lead out to blend onto the profile. Press Ctrl S to save the part, Command S on the Mac.